Like Aaron said, I'm going to talk a bit about defenses, but also about evaluation, which is quite closely related to defenses and attacks as well. Aaron also mentioned you can usually find me at MIT. My email is scasper@mit.edu. So one thing that's like centrally defined research on adversarial attacks and defenses for the past decade, like really reliably, has been this thing known as an arms race, or this game of cat and mouse, where really consistently new defenses are introduced and really quickly new attacks are developed to break through those defenses. And this is just the pace that research has continued with for the past decade really reliably. I was giving a quick lightning talk at the last FAR AI workshop in Vienna, and I gave my favorite example of like how the arms race really reliably continues here. And it's a set of papers that I had curated up to that point of different attack methods for large language models that all succeeded using a diversity of different methods in getting instructions for making bombs from state-of-the-art alignment fine-tuned models that were explicitly fine-tuned not to do things like this. But there have been some other recent developments in kind of the area. A really notable new development here comes from OpenAI 01, which is a qualitatively different system than we've been used to while studying in the past few years with chatbots. And it has some quantitatively improved capabilities on a lot of tasks related to kind of last-gen chatbots. And something that OpenAI remarked from their evaluations with 01 is that 01 Preview and 01 Mini can help experts with the operational planning of reproducing a known biological threat, which meets their medium risk threshold, which is a higher risk threshold for producing biothreats than any model has produced to date. Which is kind of concerning because we see this steady increase in capabilities without necessarily a commensurate increase in the safeguards around them. Meanwhile, the papers have started to come out this month, red teaming OpenAI 01 in order to get harmful instructions from them. So for example, here's the first paper of which I know to really successfully do this. And it was kind of remarkable how OpenAI 01, which is the system which iteratively refines responses and queries itself, OpenAI once was still vulnerable to a really simple jailbreaking strategy just involving using the past tense. And we're also seeing a lot more crossover between jailbreaking robustness research and unlearning robustness research because both of these fields are really working on really similar problems involving suppressing and re-eliciting capabilities. So I'm really excited about all of this. Recently, somewhat to my chagrin, but also I'm pretty excited about it, I've become part of this like arms race. I talked in Vienna, giving my last lightning talk about some work that we were releasing that week on Archive, which is now up. It's called Latent Adversarial Training, Improves Robustness to Persistent Harmful Behaviors in LLMs. And I was really excited about this work. I still am. I think LAT has a lot of promise, but we implemented things, we made the numbers go up, we put out the paper, we released the models, and then less than a month later, a bunch of folks at Scale AI who did some really interesting research to red team LAT models along with representation rerouting models and some other techniques. And we're pretty reliably able to elicit harmful capabilities that we did our best to make sure weren't in there, just using some pretty simple but clever multi-turn jailbreaking strategies. So the arms race is like kind of showing no signs of cooling down. I'm really reminded by of Nicholas Carlini's words from the last FAR AI workshop. In adversarial machine learning, we wrote over 9,000 papers in 10 years and got nowhere. You all have a harder problem and less time. His wisdom was to say, think very carefully about the problem you're trying to solve and try not to make it a strict superset of the adversarial example problem, because if it is, you're going to lose. So I want to actually talk a little bit about why I kind of work on evaluations, because maybe I kind of take for granted that lots of people think about these things differently, and for what it's worth, I want to share my motivation. So I agree with Nicholas Carlini that we're always going to have a gap between failure modes that we can identify and failure modes that we do fail to identify. And we can almost guarantee that this gap is going to exist because the number of inputs for systems is like hyper-astronomically large, and so is the number of contexts we could deploy them in, so we're never going to be able to enumeratively make sure that we're safe. The actual reason I work on attacks is mostly for the sake of doing rigorous evaluations. One of the motivations here involves just finding and fixing problems. And even though we're probably never going to get rid of failure modes at their root, we're still going to be able to engage in a useful process of finding issues so that we can make them less likely or less prominent. And I consider this to be like kind of the standard alignment motivation for working on attacks and defenses. But there's some other distinct reasons too. One of them is that doing good evaluations and rigorous evaluations allows for more visibility and process around AI system deployments. And that coincides with being able to make a lot more informed decision making. And by putting more stakeholders into the process between development and deployment, we can also kind of stretch out timelines, which is really conducive to making more deliberative decisions that take more risks and considerations involving safety and other societal concerns into account. Finally, evaluations allow for a lot more accountability. There's something that kind of magical that emerges just from having more transparency and scrutiny in a system. For example, if an evaluator is using rigorous and good evaluation tools in order to assess a system's safety, and they identify a risk and write this up in an evaluation report, and then if that risk later materializes and the developer is sued, the developer is not going to stand the best kind of chance in court of winning that lawsuit. So there's a really nice incentive created by using strong evaluation tools. To kind of talk about the political elephant in the room, or the things in terms of the current political climate, we all know that SB 1047, which tried to make some requirements for a lot of things like evaluations, was just vetoed. And some of the stated reasons that Gavin Newsom provided for his veto involved how AI policy needs to be informed by empirical evidence and science and fact. And I think this is really good. I think the evidence-based AI policy paradigm is laudable. But my response to Gavin Newsom, or people making similar points, would be that if we want more evidence to condition on in order to make informed policy, one of the very first things we should do yesterday is establish infrastructure and requirements for rigorous testing of models by third parties. And I've been doing a lot of work recently with a lot of very talented co-authors on trying to raise the bar for how we do evaluations. For example, earlier in the year, we put out a paper called Black Box Access is Insufficient for Rigorous AI Audits. And this paper's job was to make exactly the point in the title. And to illustrate the reason why these types of rigorous evaluation methods can be needed, let's revisit what OpenAI wrote about their analysis of OpenAI 01. OpenAI 01 Preview and 01 Mini can help experts with the operational planning of reproducing a known biological threat. And this is not misleading at all. I think they're making a good and clear claim here. But there is a way to make this claim a little bit more pedantically correct. And that is to point out that what they're identifying is kind of a minimum level of harm that they think the system can exhibit. Which is to say that if you're just doing input-output auditing of a system, the worst behavior that you identify from that system can only lower bound the model's worst case potential behavior for overall harm. So you can see the problem here. By using nothing but input-output auditing, we're always going to have an anti-conservative or like a risk-seeking bias toward underestimating the worst case possible harms with AI systems. So the project I'm going to talk about for the next couple minutes is trying to compensate for this, or trying to make it so that we can do better than producing nothing but lower bound estimates on the model's potential to cause harm. This project centered around model manipulation attacks, also known as generalized adversarial attacks. And the key to a generalized or model manipulation adversarial attack is that they can just do more than a standard attack. A standard attack can only manipulate model inputs and try to elicit harm that way. A model manipulation attack can manipulate the latent or hidden activations and also the weight space, or in other words, it can fine-tune the model. And our job with these model manipulation attacks is to answer two questions. First, how do we conservatively evaluate closed source models? If a model is deployed as a black box, we still might want to use model manipulation attacks because we can hypothesize that if one of these attacks is successful, it's because it was exploiting existing neural circuitry related to some harmful behavior, which we expect might be possible to be triggered again in the face of an anomaly or some kind of rare attack that we didn't evaluate on within input-output auditing. But also, we want model manipulation attacks just to have sane, reasonable audits of systems that are going to be open source. Obviously, if you're going to deploy a system open weight, it's a really good idea to test it adversarially under commensurate threat models, right? This sounds really obvious, but there's actually some precedent for kind of ignoring this. For example, Meta deployed its Llama 2 and Llama 3 models and reported on their safety evaluations of these models, but these evaluations only reportedly included input-output auditing, which is kind of incongruous with the actual potential for misuse that these models faced in the real world. So what was this project? The first thing we did was construct a really big data set, not quite to scale, but it involved 50 different models, which were trained with different methods, and we took different checkpoints trying to suppress harmful capabilities. In this case, ones related to harmful bio-knowledge. And we evaluated them under a suite of 10 different attacks, or I should really say 10 different types of attacks. 5 of which were input space attacks and 5 of which were model manipulation. First thing we did is did PCA on this data set. And we found that even though there are 10 attacks, there seems to be a low dimensional robustness subspace that these models lie on. It only took 4 principal components to explain over 90% of the variance in the data, suggesting that these attacks are somewhat different. They're not all exploiting the exact same mechanisms, but these attacks aren't all the same either. We looked at some principal components, but I'll gloss over this for time, and we can talk about this later if you'd like. The next thing we did is produce some scatter plots of model manipulation attack robustness on x-axis versus input space attack robustness on the y-axis. And there's quite a bit to analyze here, but I just want to point out 3 key things that it will be apparent upon enough analysis of this or a closer look at it. One is that several model manipulation attacks, specifically the 3 in the left 3 columns that we used, were able to effectively correlate with the success of input space attacks, meaning these can be used to help you predict the model's degree of vulnerability to some held out or unforeseen class of input space attacks. The second is that LORA fine-tuning in the 4th column here, in particular, was distinctly the strongest attack that we looked at, which means that if you want to make more conservative or unlikely to be lower bound estimates of risks or harmful behaviors from models, you can use LORA fine-tuning as an elicitation technique. And the third thing that we found, unfortunately, was that no models were very robust to LORA fine-tuning or lots of the other model manipulation attacks that we tried, kind of suggesting that we should probably expect some enduring risks from open source models unless we make a lot more progress on safeguarding them against tampering. Just want to conclude by saying thanks so much, and I'm really happy if you want to email me and ask for a draft of this paper. We still are going to work on it for a few more weeks or maybe a few more months, but the draft exists and I'd be really happy to send it to you and talk more about it. Thanks so much.
Great, thank you, Cass. It looks like we don't have any questions from the swap card, so I guess audience question, do you have 30 seconds shared? What about model capabilities?
Yeah.
Capabilities.
What about model capabilities?
What about them?
Yeah. So, yeah, the general class of methods that we're interested in is, you could just call them capability elicitation methods. And we're studying this in context of unlearning and relearning, right? But jailbreaking is another context where this is studied, where kind of this capability suppression process happens during fine-tuning, and this capability re-elicitation process happens during jailbreaking, right? And then you could also argue that just there's a kind of more general way of looking at this, where you might not be assessing the efficacy of unlearning, you might not be assessing the efficacy of safety fine-tuning. You literally just might be interested in just what the model, for all of the reasons why you might be interested in that. And our experiment base right now is kind of limited to the unlearning sandbox, but I'm in full agreement with you that I think all evidence is pointing to the best ways of evaluating jailbreak robustness or evaluating latent capabilities is going to involve model manipulation attacks. Thanks, Atticus.
Okay, great. Thank you, Cass.
Thanks, Aaron.